Paper number 15, question number 10. This way we have the diagram, right? I measure the distance from this fixed point on the earth toward this m as x. Then acceleration of this relative to earth is x double dot. From this m, I measure the distance to this m dash. It's y. Therefore, the acceleration of this m dash is y double dot. Since this y has been measured from m, this y double dot acceleration of this m dash is relative to this m. So therefore, the acceleration of this m dash relative to earth going to be this way, x double dot plus y double dot downward, right? Acceleration of m going to be x double dot, and this m descends with x double dot acceleration. Then the other end of the same string should have what? Same acceleration. Okay. Now I can write the length of this string. The length of this string. The length of this string I can write. That length is fixed, no? Then the length I can write like this here. From here to here, the length going to be the whole length. This I took as L, it's a fixed value. And from that L, I subtract this x. Then we get this L minus x. Okay. And this small part plus this part y. That is the length of the string. That length is a fixed length. Okay. So then for the first one, no need to write. First one, no need to write. Okay. Right. For the length of the string, for the length of the string, we can write what? L minus x plus y plus c equals capital L. What is capital L? Length of the second string. Okay. C, L are constants. C, L are constants. Constants, right? So now differentiate this twice with respect to time t. Differentiating, we get what? Differentiating, we get minus x double dot plus y double dot is equal to 0. This gives us x double dot is equal to y double dot. X double dot is equal to y double dot. For this, you get another 5 marks. It means the acceleration of m dash relative to earth, for this y double dot also, now I can put x double dot. Then x double dot plus x double dot means 2x double dot. Okay, right. Now apply F equals ma. Apply F equals ma. F equals ma, we apply this way. All right, first one. For this capital M, for capital M rightward. Here we have T1 equals M capital M x double dot. Equation number 1, 5 marks. Right. For the simple limb, for simple limb downward, yes, T2 plus mg plus T2, downward, upwards T1. Right. What do you get? 2T2 plus mg minus T1 equals mx double dot. Okay. Here you get number 2. This is 10 marks. Here, 10 marks here, right? Right. Third one, m dash. For m dash, we apply downward. What do you get there? M dash g minus T2 equals m dash times, what is acceleration? X double dot plus y double dot, no, here. x double dot plus y double dot. But y double dot is equal to x double dot. It's therefore 2x double dot. I'll write that x double dot plus y double dot m dash g minus t2. Y double dot means x double dot, 2x double dot. Then I can write 2x double dot number 3. Okay. For this also 10 marks coming. 10 marks coming. Okay. Now we can do to find x double dot this way. First equation and second equation we add. Here then t1 and minus t1 will cancel off. And third equation we multiply by 2. Third equation we multiply by 2. Then we get minus t2. Then we add this all three. Okay. First plus, second plus, third is multiplied by 2 and we add. What happens then? t1 minus t1. Here minus t2. This plus t2. All the t letters will cancel. Understand? Okay. So then you get by solving this way x double dot as this answer. Right. Do that as homework. I'm not going to write the steps in taking this. This is the way of taking that answer. Then we get x double dot m plus 2m dash g divided by capital M plus simple m plus 4m dash. Right. This is 5 marks. What is asked in there? So that the expression of m dash. Expression of m dash means this no. Its expression is 2x double dot. Then expression of m dash we must write. Therefore, expression of m dash is what? 2 times of this. 2m plus 2m dash g divided by capital M plus simple m 4m dash. This way, right? For that, you get another 5 marks. You get another 5 marks for that. Okay. Now, asking to find next what? Find the tensions in the strings. Right. T1 by number 1 we can find T1 by 1. By number 1, T1 substitute for this x double dot. By the answer this m times m plus 2m dash g divided by m plus 4m dash. Right. For this 5 marks we get. And by number 3, we can write T2 by 3. By number 3, T2 we can write here. Take this to this side and subject T2. T2 will be m dash g minus 2m dash x double dot. Okay. This x double dot answer we substitute where here. Then we can find T2. Okay. So I'll directly write the answer we get for T2. Right. T2 answer come in this way. M dash g capital M minus simple m divided by capital M plus simple m plus 4m dash. Okay. Here, substituting for this x double dot by this answer, bringing here 5 marks given. Simplifying that and taking this answer for T2, another 5 marks coming. Okay. What's asking next? Deduce that m greater than m. You know, the string this is taut. Taut means that is stretched, not slack. Therefore, this tension T2 should be positive. Understand? T2 should be positive. T2 positive. T2 greater than 0. T2 greater than 0 means this is T2 answer. This is obviously positive. This is obviously positive. Then this capital M should be greater than simple M for this T2 to be positive. Okay. Right. Then we get for this capital M minus simple M greater than 0, capital M greater than simple M. Right. This way we get that. Okay. Then here we get another 5 marks. Okay. But ask next. What happens if M less than or equal to M? When capital M less than or equal to simple M? No? Yes. Capital M less than simple M. Here, look at this. Capital M less than simple M. This is smaller, this is greater. This is what? Negative. Then tension T2 negative. Tension T2 negative means this string is slack. That string is not like this stretched, not like this straight. It is like this slack. But the string never behaves like this. So the reason is before the tension T2 becomes negative, it comes to 0. It comes to 0. Then in this case, M less than M mean this is negative, T2 negative. Before M becomes less than M, this M and simple M equal case when you consider. M equals M case when you consider this is 0 now. Then T2 0. When T2 0, string begins to slack. After that, no need to consider. Let's consider M equal M. M equal M means T2 0. Right? This implies T2 equals 0. Okay? T2 equals 0. T2 equals 0 mean, what can say? T2 equals 0 means come to here. T2, 0 by number 3. What can say? M dash you can cancel down. X double dot is equal to what? G by 2. X double dot is equal to G by 2. Then by 2, 3. Then by 3, we get what? X double dot is equal to G divided by 2. All right. Then 2x double dot, what can I say? 2x double dot is equal to G. 2x double dot means what? The acceleration of this M dash. Acceleration of M dash is 2x double dot. Therefore, M dash descends with what? 2x double dot is G, no? M dash descend with what? Acceleration due to gravity. That moves under gravity. That's what it says. Therefore, M dash. Right, this is 5 marks. Right, this is 5 marks. Okay, it says that is M dash descends with acceleration G. 5 marks. That's how we do that part. Right now. Take it part B. Yes, part B is small sphere A. Right. Of mass simple M directly collides on a stationary sphere B equal size as A of mass Km. Right. This is B. This is A. M. This is Km. Right. Let us take this velocity of A as U. Right. Then here we have AB, MKM. Let us take the after impact the velocities as V1 and V2. Coefficient of restitution is 2/3 between A and B. Find the velocity of A and B after the collision. V1 and V2 asking to find, right? So we can write conservation of linear momentum first, then mv1 plus kmv2 is equal to mu. Mu can cancel down. v1 plus kv2 equals u. Number 1 for this 10 marks. Newton's law of restitution we apply. What is that? E 2/3. What is that? Velocity of approach. It's u. And this side, velocity of separation. Okay. V2 minus V1. Correct, no? Is number 2. So this also 10 marks. Right. So by adding 1 and 2, we can write V2. V2 comes as 5u over 3 times k plus 1. For this 10 marks. And V1 can be found. First equation, from first equation we subtract second equation multiplied by k. Second equation we multiply by k. Then here we get kv2, kv1. We subtract. Then we get v1. V1 answer come in this way. V1 answer, it comes as u 3 minus 2k divided by 3 times 1 plus k. Okay. So this also 10 marks coming. Right. What's next? After the collision, the sphere B strikes on a vertical wall and rebounds. If the coefficient of restitution between the wall and the sphere B is 2/3, show if k greater than or equal to 19 over 16, that spheres A and B do not collide again. Okay. Now, this way. A moves soon after the impact. With velocity V1. Right. Then B moves towards the wall and make the collision with the wall and rebounds. Okay, this way. The rebounding velocity we can find V2. With V2 only that strikes on the wall. Then rebounding velocity is what? Multiplying with what? Huh? Yes. Coefficient of restitution between B and wall. So that is given as, if the restitution between the wall and the sphere is 2/3, that's also 2/3. Then can someone tell me what is the rebounding velocity of B? 2/3 V2. Okay, 2/3 V2. Okay, right. This is B now. Now, ask it to show this. If K greater than or equal 19 over 16, that the spheres A and B do not collide again. People really, if this A moves towards the wall, definitely collision will take, no? Okay. Then tell me the condition required. Second collision between A and B does not occur. What the condition required? First thing is, after the impact between A and B, A should reverse the motion. That means what? This V1 should be what? Minus V1. It should be moving this way. And also, that leftward minus V1 velocity should be greater than this velocity or equal. Then what happens? The collision, second collision between A and B never occur. Is it clear? Yes. Clear, no? So when this minus V1 and this 2/3 V2 are equal, still during the motion, this gap is fixed, no collision. If this is minus V1 greater, then this moves faster, that obviously no collision. So therefore, there is no collision, right? Ah. Hmm. Yes, you can write. There is no collision between A and B. Write down. There is no collision between A and B if minus V1 greater than or equal to 2/3 V2. Okay. For this, you get 5 marks. Substitute for V1. V1 answer we found this U times 3 minus 2K divided by 3 times 1 plus K greater than or equal to 2/3 V2. V2 is this answer. By U over 3 times K plus 1. 3 times K plus 1 we can cancel down. U and U you can cancel down. Okay. Substitution for this 5 marks coming. And simplify this. You get this answer. K greater than or equal to 19 over 6 for this 10 marks coming. Right. That's how we do that question. Right now. Take question number 9. Part B, question number 9. Question number 9. The balloon is rising with constant velocity u relative to Earth. Right? At t equals 0, the particle P is projected from the balloon vertically upwards with velocity v relative to the balloon. Who did this question in the paper? Who did? You did this question in the paper. You did? Yes. Good answers. Number 9, I'm saying. Huh? No. This is 2009 AL paper question. It's a very good question. Right? Okay. This balloon rising with velocity u. Right? Carefully listen to me. Maybe confusing. T equals 0 here. Right. While the balloon is moving with constant velocity. Yeah? Constant velocity. Particle P is projected from the balloon with velocity v. Relative to the balloon, no? Relative to the balloon. That means what? When you move in a bus moves with particular velocity. Right. Now you throw away a certain object and you can see it moves away from you with certain velocity. Meantime, you are moving inside the bus moves now. Okay. So therefore, understand. Relative to you mean when you throw that object, you can see it moves away from you with certain velocity. What is that velocity? That is called as velocity of that object relative to you. Since you are inside the bus, what's that velocity? The velocity of that object relative to bus. At the moment you project, you throw that, you also have in certain velocity because bus moves, the velocity of bus automatically comes to you. Then that velocity automatically comes to that object just before you throw it. Then what's the final velocity of the object? It will get the velocity you saw going away from you plus what? The velocity of the bus. Understand? Okay. Then here, same way, just before throwing the particle P, it was inside the balloon. Balloon is moving with velocity u. Then once the particle P inside the balloon, still particle P has velocity u. Now somebody throws this particle P from the balloon with velocity v. That person sees the particle P moves away from him with velocity what? V. Then what is the final velocity of the particle P relative to Earth? Upwards direction u plus v. Understand? Okay. All right. So that is what you must first understand there. Right. I'll take B as the balloon. Right. B balloon. Right. Velocity of P relative to the balloon upwards v. Velocity of balloon relative to Earth upwards u. Right. This is at T equals 0. Very carefully understand this question. Very good question. After 2009, such question we can't see in the papers. Okay. So far, no question. But there can be a chance of getting that same kind of question this year. 25 examination will be tough. Right. Right. Okay. Then this way the balloon is rising up. Okay. Then at time t equals t1, this is moving, balloon is moving with velocity u, no? This way. Very carefully understand this. Maybe confusing. The relative velocity theories we learned, if you don't have correctly in your mind, the question is definitely confusing, right? See whether I try to explain this. Right. At time t, one is the balloon suppose here. Balloon suppose here. At time t1 I am talking now. Balloon is here at time t1. T equals t1. Okay. Still the balloon is moving with velocity u. Now the particle p that was projected at t equals 0 from the balloon initially had what? Relative to Earth velocity u plus v. Balloon is moving with constant velocity u. Particle p is moving initial velocity u plus v under gravity with retardation g. So, since its initial velocity of the particle p is u plus v, we can think at time t1, the balloon has risen this height. Since this particle p had u plus v, a velocity greater than the balloon, we can assume the particle p is what? Above this level of the balloon at that moment. What do you say? Okay? Right. We'll assume like that. At time t equals t1, particle p is right somewhere here. Particle at that moment, particle p is somewhere here. At that moment, particle p is somewhere here. Particle p is somewhere here, right? This time moment is what, people? Time moment is t equals t1. That means the observer in the balloon at time t1 observes the position of the particle p. The observer can see what? Particle p is at time t1 at a height this much above the level of the balloon. Am I correct? Yes. What happens next? At time t1, second particle q. Second particle q is projected with velocity v. Okay. Okay. Second particle q is projected with velocity v. Okay. Right. So then what is the second particle q? Its velocity related to Earth u plus v. What is saying next? Right? Another particle q is projected from the balloon vertically upwards, also with velocity v related to the balloon. The two particles p and q meet at time t equals t2. Right. So then what happens? Q here at time t equals t1. Okay. Now q moves with velocity related to Earth u plus v upwards. Once the q starts from here to move upwards with velocity u plus v, p has what? Certain velocity that is less than initial u plus v. Why? P is moving under gravity with retardation, velocity decreases. Now anyway, people, once this p and q move, they now move under gravity. This way p moves under gravity and comes to zero velocity. Understand? And going to maximum height while it is coming down and while this q is going up, they will meet one location. Understand? The meeting point, of course, I'll mark somewhere here. This moves this way, p moves this way, going this p to highest point, coming back, and while going q upwards, somewhere here, they can meet each other. While q moving upwards, p moving downward, at t equals t2, we are given they meet. Understand? So this is the story. Okay. Therefore, the velocity of q related to the balloon also upwards v. Right. Now asking what? Sketch the velocity time graph separately for the motion of p relative to the balloon. P relative to the balloon. Velocity time graph, we need to sketch p relative to the balloon during what interval? During, yes, time 0 up to what? Time t1. In this interval, just before projecting what? Just before projecting what? Particle q. You know, first one, VT graph of P relative to balloon in what interval? T greater than or equal to? No. T greater than or equal to 0, less than or equal to T1. This interval. Right. What is the velocity? Velocity we need. Initial velocity what? Initial velocity of P relative to balloon initially upwards P. Okay. Right. Now we need next one to sketch the VT graph. What? Velocity of P relative to balloon we know. Acceleration of P relative to balloon we need. That you have to calculate. For this you get marks. For this you are given 5 marks. Acceleration next. Acceleration of P relative to balloon. How to write? Acceleration of P relative to Earth. Acceleration of Earth be like this, no? Acceleration of P relative to Earth while P is moving this way. What is the acceleration? Upwards minus g. Retardation, no? Upwards minus g. What is this? Acceleration of Earth relative to B. We can change this order. Acceleration of B relative to Earth. Balloon relative to Earth. Balloon is moving with constant velocity. No acceleration, 0. And then what is this? Upwards direction minus g. Okay. What do you mean by this? What do you mean by this? The particle has, P has relative to balloon retardation g. Understand? Retardation g. So what is the VT graph? For this you get 5 marks. Right. You see we have now VT graph. Time t. This is the velocity of P relative to B. Initially it is V. This is the time t1. This is time t1. Right. Retardation is g. Decrease in this way. Right. This angle is theta. What is tan theta? Tan theta is g. This way, right? Here O, A, B, C. O, A, B, C. Right. Right, people know this OABC area, OABC area gives us what? Displacement moved by P relative to balloon during time t1. Am I correct? This OABC area gives the displacement of P relative to balloon during time t1. It means what, people? It means what? During time t1, after t1, balloon is here. After time t1, P is here. Relative to balloon means an observer in the balloon observes at time t1 this P. That observer can notice the particle P is from the balloon this height above. Understand? Then observer determine relative to me, particle P has ascended this height. Relative to mean means what? Relative to balloon. Therefore, this height is given by what? This area. What do you say? What is this area? Displacement of P relative to balloon. It means when an observer in the balloon observes at time t1, the observer can see this height particle P has risen from the place of the balloon. So therefore, this height is given by what? O, A, B, C area. Understood? Okay, that's given by O, A, B, C area. Right. So then for this 10 marks come in VT graph. Right. Now, if I take this velocity to be W, then we can write what? Tan theta. Tan theta V minus W divided by T1. Tan theta is G, V minus W divided by T1. Right. So then you can write subject in this W here. We get what? GT1, V minus GT1W, right? W is V minus GT1. For this, you get another 5 marks, right? This is V minus GT1, right? Okay. Now, secondly, asking the VT graph, Q relative to P. Q relative to P, right? Second one, number 2. VT graph of Q relative to P. Q relative to P. In what interval? T less than or equal to T2, greater than or equal to T1 in this interval. Right. Okay. We suppose to start to draw VT graph of Q relative to P at time T1. At time T1 is here. Q relative to P. At time T1, where is Q? Here. Where is P? Here. Understand? Right. What is the velocity with which this Q begins to move? Relative to balloon upward speed. At this same moment T1, what is the velocity of P relative to balloon? What? What is the velocity of P relative to balloon at time T1? This. What is this axis? Velocity of P relative to balloon? No? Right. Correct, no? Then we start to sketch VT graph of, right, Q relative to P, starting from this time moment. Then first of all, we have to calculate what? Velocity of Q relative to P. Secondly, velocity of acceleration of Q relative to P. Both we need. Then we'll calculate that. At time T1, at T equals T1, velocity of Q relative to P. How to write? Apply principle of relative velocity. VQ B plus VB P, like this, VBP. All right. VQP. All right. What is QB? At time T1, V is projected with velocity V relative to balloon, upwards V. This one we can interchange, put in minus sign, VPB. All right. Tell me, what is this? VPB at time T1? VPB. PB is this here. Time T1 means this. What is that? V minus GT1. That's also upwards. Understood? Right. VQP. Right. V minus GT1. That's also upwards. Right. For this one, 5 marks given now. Simplify here. V and V we can cancel down. Minus minus plus what? GT1. Okay. VQP upwards GT1 for these 5 marks. Right. To sketch the VT graph, we need both velocity and acceleration. At time t1, velocity of q relative to p, just now we found gt1. Now, to sketch that, we need what? Acceleration. Tell me, people, acceleration of q relative to p. We told when both are moving under gravity, both may be moving upwards, both may be moving downwards. One is upward, other one downward. Can remember in one discussion I show velocity acceleration of any object relative to other is what? 0. Understand? We did this, no? One question. Yes. So therefore, acceleration of q relative to p is 0. All right. Where? At time, when at time t equals t1. Acceleration 0. What velocity it has? It means what? Yes, no acceleration means velocity is constant. Understand? All right. Then we can sketch the VT graph of Q relative to P. Here, time T1, time T2. It is now GT1. This is GT1 now. For this, you get 10 marks. Right in this one, you get another 5 marks. Right. Correct, no? Right. Now, let's ask you next. Let's ask you next. Hence, to otherwise show that T2 is this. Right. Now, carefully listen to me. Carefully listen to me. We will pay our attention at time T1. At time T1, Q begins to move from here with velocity V relative to balloon. At that moment, P is this level at the height given by OABC area. Understood? Right. After time T1 onwards, we have sketched VT graph of Q relative to P. VT graph of Q relative to P. VT graph of Q relative to P. Q relative to P means the object P is what we have to stop, no? That means since we have sketched the VT graph of Q relative to P time T1 onwards, at time T1 onwards, we have to stop this P. P we have to stop here. Why? Because we consider the motion of Q relative to P. I told in the relative velocity, listen, Q relative to P means now P is at rest. At time T1, P is here. That moment onwards, we stop P because we consider the motion of Q relative to P. Now P is resting here. Now, to meet this P, this Q should move what? This same height, no? Same height, no? Then only Q can meet P. We are given P and Q meet at time T2. Then from T1 up to time T2, the displacement moved by Q relative to P should be equal to what? This, no? This side. Am I correct? Yes or no? But from T1 to T2, this area gives what? This area gives what? This axis is velocity of Q relative to P. This area gives us what? While P is at rest, the displacement traveled by Q, no? This area. Therefore, people, this area should be equal to what? That OA, BC area, no? At time T2, when they meet. Yes or no? Yes, right? Then if I take this as a DEFG, a DEFG, very carefully understand this. This area means what? From time T1 to T2, the displacement traveled by Q relative to P. Why? Because this axis is velocity of Q relative to P. Therefore, this area is what? Displacement of Q relative to P. Understand? Right. So then this area and this area should be equal at time to T2 when they meet. Yes or no? Now by equating that, we can take the time T2. Okay, write down like this. The, I don't know, OABC area is equal to DEFG area. OABC area is equal to DEFG area. Right, equate them and take the next answer. DEFG area DEFG area is equal to OABC area. DEFG area mean people T2 minus T1 GT1 is equal to, this is a trapezium, it's half sum of the parallel sides V plus V minus GT1 into T1. For this 5 marks. Right? I'm not going to show you the simplification steps. You can simplify this. Then you get the first answer T2. T2 V over G plus T1 over 2. Some steps come in here in simplifying to this as homework. Another 5 marks come in for this last answer. Right now. What's the next part? Hence, or otherwise, show that T2 this one, okay? Show further that the velocities of Q and P when the two particles meet are. Show further that the velocities of Q and P. Velocity of Q and P means what? Relative to Earth. We can use the equation of motion there. Okay. Once they meet, okay. Initially, relative to Earth, what is the velocity of P? U plus V. It moves upward with retardation G. It moves during a time interval T2. Why? Asking what? Asking what, people? We need to find what? Show further velocity of Q and P when the two particles meet. When the two particles meet, what is the time elapsed? T2. Particle P moves during a time interval T2. Particle Q moves just before they meet, time interval T2 minus T1. Understand? Then apply equation of motion. Okay? All right. You can apply B equals U plus AT upwards for P. Its final velocity will take as W1. Its initial velocity with respect to Earth U plus V, move in with retardation G, time is T2. Okay, 5 marks for this. Then substitute for this T2 time we got V over G plus T1 by 2. Then we get W1 U minus GT1 by 2. 5 marks here. Now Q V equals U plus AT, we apply for Q upwards. I'll take that as W dash. It also have in velocity related to Earth U plus V. Move in with retardation G. But the time is what? T2 minus T1. Understand? The total time during which Q moves T2 minus T1. Because it is projected at T1, P and Q meet at time T2. Time interval is T2 minus T1. Okay. For this T2 minus T1, this is also 5 marks. Okay. T2 minus T1, you can subject by this. Right. So T2 we know. Put that here. You get W dash as Q plus GT 1 by 2. For this, we get 5 marks. Right. Correct, no? Then that answer is coming. It's a good question, people. There can be repeating this kind of question in the future. So therefore, go through this. Right. Okay. The next one, 9 part B. Right, 9 part B. Particle is projected from a point O on the ground at an angle alpha to the horizontal. If the range of the horizontal plane is R, show that the equation of the path is this. Right. This is y-axis. This is x-axis. Okay. You see the particle is projected with initial velocity u. Okay. Right. This horizontal range is R. Horizontal range is R. Right. Suppose this is a point. Point A here, the point O. Okay. This angle is alpha. Now, for this OA motion, we apply for whole motion, we apply S equals ut plus half at squared vertically upwards. For this OA motion, that means no displacement, no, 0. U sin alpha t minus half gt squared. Subject t. It's 2u sin alpha of g. Right. For this 5, answer 5. Now we apply S equals ut plus half at squared rightward r u cos alpha. Is this 2u sin alpha over g, but this a is 0, horizontally no acceleration. Right. From this we get, for this 5, r comes as u squared over g sin 2 alpha. Right now? Yes. Now asking the equation of the path. Then we select a point P after time t of projection with coordinates xy. Equation of path means we have to obtain a relation between x and y. Okay. We have to take the equation between x and y. Suppose this is x, this is y. All right. Now apply for OP motion horizontal s equals to t and s equals to t plus half at squared vertical upwards, and take the equation this way. Couldn't you get the paper now 15 and 16? Do you have the papers? No. Sixteen copies available, but 15 only one copy available. Hmm. Right. Pass this. 16 only available. Take your copy and pass. Okay. For this OP motion now, for this 5 marks you get. For OP motion, we apply S equals ut rightward. Once the particle moves from O to P, horizontal displacement is x. Initial velocity is u cos alpha times t. T, you can write x upon u cos alpha. Five marks. And now apply S equals ut plus half at squared this way. Right? Right. What is the height? Y. What is the initial velocity? U sin alpha. U sin alpha. Okay. Yes. Time is t. T is this answer. X over u cos alpha minus half g. T squared means this squared. U squared cos squared alpha. Okay. For these 5 marks, simplify this now. U and A, U can cancel down. We get Y, X tan alpha, minus Gx squared over 2U squared cos squared alpha. For this also 5 marks coming. Okay, now here, this U squared, right? And G over U squared, this part, G over U squared. U squared over G, I can subject by this and put there. Then we get the equation of the path. I can substitute that like this. Y equals X tan alpha minus X squared over 2 cos squared alpha X squared over 2 cos squared alpha into G over U squared. All right. This G over U squared part, you can subject here. What is that? Sine 2 alpha over R. Sine 2 alpha over R. Sine 2 alpha over R. Okay. Now simplify this. You get, what do you get there? Y equals X tan alpha. If sine 2 alpha, you can write how? 2 sine alpha cos alpha, no? 2 sine alpha cos alpha. This 2, 1 cos alpha with this we can cancel down. Then what do we have? Sine by cos is tan X squared tan alpha over R. X squared tan alpha over R. X squared over R tan alpha. Let us take this as star. This we need later. And now we can take X tan alpha out from the right hand side. Here 1. Once we take X tan alpha out, we get within bracket X upon R. For this 5 marks, this is the equation of the path asking. Correct, no? Okay. Now what is asking next? If there are 2 points on the path of height h at a distance 2a apart, show that this answer. It means this. It is projectile. It was projectile. This is a trajectory, right? The path. The path. There are 2 points on the path with the same height. This is h. This is also h. The corresponding horizontal distance, if I take this as x1, right? This I take as x2. We are given in the question, but if there are 2 points on the path of height h at a distance 2a, the distance between these two going to be 2a. In other words, x2 minus x1 is 2a. Okay, right. Then we can write the x-axis, this is y-axis. x2 minus x1 is equal to 2a, right? This is, say simply, 5 marks for this. Right. Now, people, this equation is the equation of this path. This height h mean, here the y. Then since at this point and this point, this y value is h, I put h here. Okay. Then I take quadratic equation. Ah. Put in y equals h in star. What do you get there? H equals x tan alpha minus x squared over r tan alpha. Bring these terms to left hand side. Tan alpha over r x squared minus tan alpha x plus h equals 0. Here, this is a quadratic equation in x. This quadratic equation in x we obtained, put in y equals h in this. That in the sense, on this path, there are 2 points of height h. For this height h, the x value is x1. For this height h, the x value is x2. Therefore, in this quadratic equation of x, the two x values after solving this quadratic equation we get should definitely be, but one is that x1, other one is that x2. In other words, x1 and x2 are what? Roots of this. Understand? X1 and x2 are roots of this quadratic equation. Am I correct? Okay. Then write down here. Here, for this 5 marks, and this one 5 marks. Then write down the roots of this quadratic equation in x. The roots of this quadratic equation in x are x1 and x2. Are x1 and x2. Are x1 and x2. Right. Then tell me sum of the roots minus b divided by a. Minus b divided by a. But minus tan alpha divided by tan alpha over r. What do you get there? We get canceling this to r. Sum of the roots of a quadratic equation, you know, right? Let us take this as number 1. Do we have number 1 before this? No, yeah, no, yes. But product of the roots c over a, hr divided by tan alpha. HR divided by tan alpha, right? Number 2. For each 5 marks coming. Okay. Now we can write x2 minus x1 perfect squared. X2 minus x1 we wrote somewhere here, 2a, no? This x2 minus x1 perfect squared, you can write people like this, no? X1 plus x2 perfect squared minus 4x1 x2. Am I correct? Can you write this left hand side this like this? What do you get? X1 squared plus x2 squared minus 2x1 x2 is the left hand side. Here also when you simplify, what do you get? Same thing. But x2 minus x1 is what? 2a. We are here. Put 2a here. 2a perfect squared. x1 plus x2 going to be what, people? R squared minus 4 times hr over tan alpha. Right. Here we get 4a squared. I think you get the answer by this. We can take R out, or the R inside, for which 1 over 10 alpha is called alpha. This is the asking answer. 5 marks. Correct, no? Right. Who did this question in the paper? Huh? Did got this answer? Hmm? Right. So this type of approaches you must expect in the projectile question at the paper. Okay. This kind of approach using quadratic equation and using its roots, getting the answers. Yes. I move next to number 12. Number 12. Part A, this question. Yes. So the diagram there. Right. Yeah, that's a normal reaction. R. People, this end D has the tendency to move this way. Friction coming opposite. Then frictional force this way. This is 2W, no? The length is A, A. Right. B and C, the weights of the rods AB. Okay, right. Well, the ND is on horizontal, half horizontal plane. B and D on the same level. The system is kept in equilibrium with the rod making 60 by horizontal force. Stop talking, people. Right. The coefficient of friction between the surfaces at D is mu. Show that mu greater than or equal to root 307. Find the horizontal and vertical components of the reaction exerted by BC on DC at C. Also show that P is this much. Yes, who did this question? It's a very simple question. Okay. Yes, I can remember one past paper question was very similar to this. This question I took a provincial exam question, right? So one past paper question also available in jointed roads. So after this, that question we can do, right? Okay. For the diagram is 10 marks, right? The 10 marks you get when you mark all the forces correctly. Otherwise, no, you lose marks, right? Now you can write for the equilibrium, of BCD part. BCD part. This is C. BCD part. We take moment around B. We take moment around B, anti-clockwise moment, right? We take moment around B, around this point. We take the equilibrium for the equilibrium B, C, D. Then this F passes through the point B, no moment. W to W, but anti-clockwise, R clockwise. C joint doesn't give because they get cancelled, the forces. Okay. Thereby, you can find this R, right? What do you get there? W into, right? When you produce this way, this length, W into A cos 60. 2W here, drop this way, from here to here. What is this? Drop perpendicular from here to here, 2A cos 60. From here to here, A cos 60, 3A cos 60. Correct, no? Right. 2W into 3A cos 60. And R gives clockwise moment, the distance from here to here, OA cos 60. A cos 60 you can cancel down. Okay. This gives R 7W by 4. So the moment equation 10 marks. For this R, 5 marks. Okay. Now, for the road CD here, for the road CD now. For the road CD, we take moment around C. Since we know this R, we can find this F. Okay. Now we can write for the road CD, take moment around C, anti-clockwise moment. What do you get? W, 2W and F both will give anti-clockwise. R gives clockwise. Okay, right. We get F into F gives anti-clockwise moment. This height we need. What is that? 2A sine 60, no? 2A sine 60. F into 2A sine 60. Okay. 2W also given around C anti-clockwise moment. So 2W, if I produce this way, this length we need. Okay, this is 60, right? So therefore, this is A, this length is 2A cos 60. 2W, A cos 60. Then R gives clockwise movement equals R line is this, perp distance is this length. Okay. What is that? If this is 60, this is 60, 2a cos 60. So this another 10 marks. People simplify this. Put it R value this way here. And you get this F value. I'm not going to show you the steps of simplifying this. F comes as 3W over 4 root 3 for this 5 marks. Okay. Now, at this ND is in equilibrium without slip-in. What's the condition required? Mu should be greater than or equal to modulus of F over R. In this case, no need to put modulus of F over R. Reason, both this F and R are what? Obviously, positive values. So there we put modulus. In one occasion, F over R, one of them become negative. Mu greater than negative mean, it says mu can take negative value also. Understand? So then to avoid that one, we put the modulus. But obviously, both F and R positive, no need to put modulus. Right? So then you can write for the equilibrium at D. For the equilibrium at D, mu should be greater than or equal to F over R. Right? Mu should be greater than or equal to F over R. All right. So then you can write 5 marks here. Right. Then substitute here. Mu F 3W over 4 root 3 R 7W over 4. So this gives us mu greater than or equal to root 3 over 7 for these 5 marks. Okay. Find the horizontal and vertical components of the reaction exerted by BC on DC at C. At C, the horizontal vertical components asking. At C, right? I draw that. This question you must do again yourself as homework people and go to the paper. I'm sure there'll be nothing to do at the paper, in AL paper, because almost all areas of a question which can come in different ways, I'm covering by preparing the paper. So that finally, hardly any chance of missing any type of question in a certain lesson after completing the paper discussion. Okay, so therefore, once you do the questions, all the questions 2 or 3 times in the papers available just before examination, I think most of the question will be available in the papers. Right now? Yes. Right. That's not a boasting because, you know, the structures only possibilities of giving a question under the jointed words. One type is this. Another type, of course, I put today paper. Okay. Previously, we did some questions on the few types available. So once we do like this 5 papers, 5 different types, 10 papers, 10 different types, then hardly any different types of come into the paper. No? That's what. Then not a miracle. Right. Okay, now this way we can mark what the DC. Here we notice the frictional force F from a reaction R. 2W is here. Okay. I take the horizontal component here, X leftward, then vertical component here, Y upwards, this way. Right. Now you can write the equations for the equilibrium of DC. You can resolve upwards. This not only I drew there, but you get R plus Y equals 2W, 5 marks. Right. People, we have found R earlier. Put that R here, subject Y. You get for Y this answer, W by 4. I'm not going to show you the substitution for R and simplifying and getting the value of Y that you can do. We can resolve horizontally. X equals F, right? Then if we know, then X is 3W over 4 root 3 for these 5 marks. Also show that the value of P, yes. Right. This end A is smoothly hinged, people. Yeah. Then on the road AB, there's another reaction at A. Now what is asking? Next one asking the force P. Next one asking the force P. To get the answer of force P, this is what I do. Around this point A, okay, I take moment around A for ABC part. For ABC part. Huh? For ABC part. If you take the moment around A for A, B, C, D, also you can take the answer. The disadvantage is when you take moment around A only for A, B, C part, here at the C, right? So if I mark on CB road, the horizontal is X this way, vertical is Y downward this way. Then this X passes to the point A, doesn't give moment. For the moment equation, how many forces then come in? When you take A, B, C part, W, P, W, Y only, 4. If you take A, B, C, D part, these two won't come because this X here act, Y also act, no? Then what are the forces coming? W, P, W, 2W, F, R. More forces coming. Understand? So therefore, you get the same answer for P, but taking moments is what? Little bit inconvenience. Why do we get back to get the answer if we have easy method? Then we take what? For A, B, C, we take moment around A. Okay? Right. Then you get the next answer. Right. Start. That's the importance of this question, people. If you wisely look at this, you have to take like that. Okay? Then I draw that like this. Here, A, 60. The horizontal is X going this way. Vertical is Y this way. And W is here. P is here. And W here. This is A. Right. For ABC part, take moment around A. Take moment around A. Y, W, W. Around AQ, anti-clockwise movement. P, clockwise. No, right. So this W, A cos 60. This W, 3A cos 60. This Y, 4A cos 60. And this P, 2A sin 60. Correct, no? 2A sin 60. 2A sin 60. For this 10 marks coming. Then people, you know why we found earlier? Put that here and take the answer for P. You get this answer. P, 5W over 2 root 3. 5W over 2 root 3. All right. So 5 marks for this. Right. Okay. 12 part B, circular motion part. Oh, right. Yes, given question like this. Right. We'll do the diagram there. Here's the particle. Nice. R, theta, mg weight, with this way. Here the particle P is projected with velocity downward u. Particle is P mass is m. Radius is r. I take this is the potential energy 0 level. Okay. This first question asking, particle P is given this, velocity V is given by this. Okay. Applied conservation of mechanical energy is height given as h. Given as h. Right. We'll write first energy here is r. Kinetic energy half mv squared. This length is r cos theta, no? Then minus mg r cos theta. Half mv squared is the kinetic energy at that point. Potential energy mgr cos theta. Initial energy here, half mu squared plus what? Mg h. Half mu squared plus mg h. 10 marks for the energy equation. People, simplification now we do now. Earlier we used to do, but now you can do the math homework. Simplify this, you get v squared, you get this answer. Okay, 2g h plus r cos theta. 5 marks. At this moment, show that the reaction on the particle by the tube is apply phi cos m a towards center. Hmm? Hmm? This is theta. Therefore, this angle also theta. R minus mg cos theta. M times. What is the centimeter expression? V squared over r, no? R is radius. Yes. For this 5 marks. Right. Then here, yes. Subject in R, taking this right hand side. Okay. Substitute for this V squared here and mg cos theta. Right. For this V squared, we can substitute here. For this 5 marks. And simplifying this, you get the required answer for R. M upon R. Q squared plus G times 2H plus 3R cos theta. This is 5 marks. Right. Okay. Right. Now asking this. Show that the direction of reaction changes. Direction of reaction changes as the particle P passes the point, making an angle cosinus this much with upward vertical. So this reaction R, right? So early stage, the particle will make contact with the outer surface, internally outer surface. Once the particle moves like this and especially passing above this level, once it comes this way, certain moment, it may touch inside, inner surface this way. That occasion R goes away from the center. So initially the R is towards center, inward. Once the particle rises like this, R can be one occasion turned into what? Outward from the center. From inner to out, that moment is a moment of change in the reaction. That moment of change in the reaction, the reaction R suddenly comes to what? Zero. That is the moment the reaction changes the direction. Okay. Then you can write. When R changes the direction, when R changes the direction, R equals 0. R equals 0. 5 marks for that. R equals 0. R equals 0, no? 5 marks for this. Huh? Substitute for R, that answer. M of R, U squared plus G times 2H plus 3R cos theta equals 0. Okay. Once you simplify this, you get for cos theta. I'm not going to show you the steps of simplifying this. You can do that as homework. U squared over 2GH over 3GR with having minus sign before it. Okay. With upward vertical, right? You can see this cos theta has negative arms. Cos theta negative means what? Cos theta becomes negative first time in the second quadrant. That means this theta is what? Cos theta negative means theta should be what? More than 90. More than 90. Understand? Okay. Then, really, this change in the direction of R occurs after this level. Somewhere here. Then I mark that position here. Okay. This is the angle theta given there. But question asking what? The angle with upward vertical. This is the one asking. Suppose beta. Beta only asking. Understand? You know, theta plus beta, 180. Subject beta, 180 minus this. What is cos beta? Take cos on both sides. Cos 180 minus theta. What is cos 180 minus theta? What is cos 180 minus theta? Huh? Minus cos theta. Minus cos theta. Minus cos theta. All right. Substitute for cos theta. This answer. Cos beta. U squared plus 2GH over 3GR. What is beta? Cos inverse. This no. Correct now the answer. With upward vertical. Beta. People here 5 marks. Take in this way another 5 marks. Right. That's how we take it. Right. What's next one? If the particle leaving from D passes through B, not projectile motion. Particle leaves from D. Then we must first find the velocity when the particle passes the point D here. That velocity can easily be found how? Yes. Once the particle reaches this point, this angle theta will be equal to what? 180. Put theta 180 where? Here. Then we get that moment the velocity with which it comes out. Now on the projectile motion, we are given the particle will be moving through the point this B. Now that is the projectile motion. Yes. We count that now. Okay. I take this velocity as V1. How to write V1? Put theta 180 here and take the root. Right. When theta equals 180, put over there, we get V1 squared. U1 plus 2G. When you put theta 180 means cos 180 minus 1. H minus R. H minus R. This is 5. Right. Now, we can consider the projectile motion like this. At the height R only, the particle now moves horizontally with velocity V1 and another height distance R, right? It moves like this. All right. So this is the point B, O, D. Right. Put S equals UT leftward, then we get R V1T, subject T by this, R over V, 5 marks for this. Put S equals UT plus half A squared, downward, for the motion from here to here, moves downward R. Initial velocity 0, U0, no, it has horizontal, no, vertical downward, no velocity. Half G T squared means R squared over V1 squared. Okay. Yes, here we get 5 marks for this. Okay. Then here 2V1, this 1R we can cancel down with this. 2V1 squared is equal to GR coming. Okay. Right. For these 5 marks and substitute for this V1. What is V1 answer? V1 squared answer we know here. Put that V1 here. And keep simplify this. Then you get this asking answer U. Yes. I'm not going to show you the simplification. Only thing is V1 squared we have to put here. That you can do. Then we get U G over 2 5R minus 4H to the power half for this another 5 marks. Those simplification you must do as homework. Huh? Next one, take question number 13. Question number 13. Take question number 13. Right? Not only come into the paper discussion, writing the paper and coming to the paper discussion is very worth people. Reason. At that moment, now you make certain struggles of getting the answer. But that occasion, the struggles, you can very easily analyze once I do the question here. Then only you can remember all the things. Otherwise, just come in here and taking down everything on the board. Of course, you won't get nothing. This is like just a class. Write the paper, and then next week come to the discussion. That occasion, you will feel something. That is the experience, and that will be permanently stored in your mind. That's what you must do. Otherwise, just come into the discussion of the paper, right? And copying down everything on the board. Hmm. Not worth. Hmm. Okay, right. Next one, 13 part team. Rhombus is formed by using 4 equal uniform rods AB, BC this way, weight W, length 2A. Rhombus is suspended from A, and rhombus form is maintained by a string AC, and it is in equilibrium so that BAD 60. Find the magnitude and direction of the reaction at the joint B. Yes. Hmm. Right. This way we have rhombus. Okay. Here I'll take this tension T dash here T. The system is symmetric, no? Then reaction at this end, that 10 being equal. Huh? System is symmetric about this line, no? This is B. Here C. This is D. Okay. I'll mark this way. W here. W. BAD angle is 60 means this diagonal bisect the angle at the vertex 30. It's also 30. And this opposite angles are equal 30 here. 30 here. Right here. You can mark This way vertical component I take y, horizontal x, this way x, this way y. Right. Find the magnetic direction of the reaction at the joint B. For the rod AB, take moment around B, take moment around A. Right on, it is. For this whole diagram with marks correctly marked, this forces correctly marked, you get marks 10 marks for this. Right. The length is 2A, no? We've been given length. Yes. For the rod AB, take moment around A. We take anti-clockwise moment. Only W gives anti-clockwise moment, Y and X both clockwise moment. Huh? W into A sine 30, no? A sine 30. Y 2A sine 30. X 2A cos 30. 2A cos 30. For this 10 marks. For this equation, 10 marks. Right. By simplifying this, we get x plus y w over 2 root 3, equation number 1, 5 marks. I'm not going to show you the steps in simplifying this. You should be able to do them now. Now, for the rod CB, we take moment around C. Okay. For the rod CB, for CB, we take moment around C. Suppose anti-clockwise moment. There we get W and Y, anti-clockwise moment takes clockwise. Right. W times what? A sine 30, no? Y 2A sine 30. X 2A cos 30. For this also 10 marks. Substituting for cos 30 and sine 30, simplify this, you get root 3x minus y equals w by 2. Equation number 2, 5 marks. Okay. Substituting for cosine and simplifying and taking this way, now you can manage that we did in the kindergarten. Right. So, by solving 1 and 2, we get y0 x w over 2 root 3. Solving these two simultaneous equations also, I am not going to explain you, right? You can take that. Right. So by 1 and 2, by 1 and 2, y0, 5 marks, x w over 2 root 3, 5 marks. Right. Correct, no? Next one. Show that the depth from A to the point of intersection of the lines of reaction at the joint A and B on the road AB is root 3A. Right. Now you know this. When I consider people, the road AB, okay, road AB here. This is B. right? At B, leftward X available. Y0, no, we told. Here W. At A, finally, here, at A, there is a joint. Then in the joint, by the nail, certain force coming toward this rod AB. And this T dash also acting at A. By that also there is a certain effect. By this T also, there is a certain effect at A. Then at A, there are three forces. T dash, T, and that nail also given. Finally, these all three forces together give one single force to what? End A. That single force only we define here as what? Reaction at A. That is now single force. That single force, if I mark here, this rod AB is now equilibrium in under the action of how many forces? Rod AB is in equilibrium under the action of how many forces? Three forces. In covalent forces, can remember, we learned whenever any object is in equilibrium under the action of three forces, either the three forces must meet in a point or they must be parallel to each other. They cannot be parallel in this case because X and this W, they meet here. People look at this. They meet here. Therefore, definitely this reaction at A should be passing through this point. All right. Asking what? The distance, vertical distance to this point. That is nothing but this height, no? This height only we need to find. What is that? This angle is 30. This is two-way. Then what is this two-way? Cos 30. Constant. Two-way cos 30. Okay? Okay, in the first part, we got this x as this way, but we have not written that in words. You must write. Therefore, the reaction at B is W over 2 root 3 horizontally. That should be written in words. For that, you get another 5 marks. I'll write on that one earlier for the B. First question. Write on. Reaction at B is horizontal of magnitude W over 2 root 3. Write that in words. Five marks for that. 5 marks for that. Okay. Next one. Here, 2a cos 30, root 3a. Root 3a. Ask that also in words. Right. Write down. Therefore, depth from A. Depth from A. Depth means vertically downwards the distance. Therefore, depth from A to the point the three forces meet is root 3A. Is root 3A. 5 marks for that. What is asking next? Show that the tension in the string AC is 2W. That means this T we need to find. Okay. You can now write it like this. How people? This system is symmetric. Therefore, reaction at D and B equal. Then D has X this way. We told Y0, no? Y0. Then what we do? This BCD part we resolve upwards. T upward, only two forces, W downward equals downward, 2W. Yes, right or like this. But due to the system is symmetric, the reactions at B and D are equal. The reactions at B and D are equal. Then how do you mark the reactions at D on the road CD? The image of this X should be here, image of Y should be here. Okay. Now this BCD equilibrium, we resolve forces upwards. For that statement, 5 marks. Write down. Now, for the equilibrium of BCD, upwards, what do you get? T equals to W. For this, another 5 marks. That's the end of that question. Okay. Now, burst notation part. Right. Framework, 5 light rods, A, B, B, C, C, D, D, B, and D, A. As shown in the diagram, D, B, D is equal. Okay. AB is vertical and BC horizontal. Framework smoothly hinged at A to a fixed point and is in equilibrium in a vertical plane. Weight 300, 100 are loaded at the joint C and D, respectively. At B, a horizontal force P is applied. Yes. Find the value of P and horizontal and vertical components of reaction at T. Yes. You do diagram there. Diagram complete කරලා නෑ නේද? අයියෝ ගන්නෑ. පන්තිට එන්න ඉගෙන ගන්න. කරන්න ඕනේ. ඔව්. ඔව්. ඉක්මනට කරන්න ඕනේ. Yes. This is the diagram. D here 100. This is 300 now. B. C here. P. Right. So we are given in the question BDDC equal. BDDC equal means this two lengths equal. Therefore, this angle is this angle equal. Yeah. The angle here given as 30. Then therefore this also 30. BD and this AB, vertical, horizontal, therefore here 90, this is 60. Right. Here 90, this is 30, therefore. A is hinge. I take horizontal component as X, vertical component as Y. X, Y like this. Huh? Right. I'll take its length as A, given no equal, assume as A. Right. Right. People now, if I assume this as A, AB is here 90. AB sine 30 means this length, no? AB sine theta is what? A. Hmm? Right. It's not like this. Let BD equals CD equals A. AB sine 30. What is AB? This length. This is 30. Then opposite side is BD. AB sine 30 is A. Then AB becomes sine 30 is half, no? 2A. This length we need. Now, for the equilibrium of the system, we take moment around A. 100, 300. Q clockwise moment. P anti-clockwise moment. Then we get the P. Ah. For the system, moment around A anti-clockwise. P into AB, 2A. Yes, 100. People, for this 100, what the powerful distance? Yes, no? This length, from here to here, the length. That length is nothing but, if I produce this way, the length from here to here, no? This length being equal. What is that? A cos 30. A cos 30. 100 into A cos 30 plus 300 when I produce this way. The required distance to take moment around A going to be this length. That length is nothing but this length. What is that? This one, A cos 30, this one, A cos 30, 2A cos 30. 300 into 2A cos 30. 300 into 2A cos 30. Correct. For this 5 marks coming. Okay. Substitute for cos 30, I'm simplifying this. We get P 350 root 3 by 2 newtons. 5 marks for this. 5 marks. This way, you should be able to identify the lengths. Now, what is asked next? Horizontal and vertical component of the reaction at T. How to find that? For the system, we resolve horizontal and vertical for its equilibrium for the system. Right. Resolving horizontally and vertically. What do you get? X equals P. P is this answer. 350 root 3 by 2. Vertically, Y equals 100, 300, Y 400. 5 each. Right. Okay. Hence, determine the stress in the rod AD with its nature and find the stress in the rod AB. Hence, not using the Bose notation. I think most of you have used the Bose notation to determine the stresses in AD and AB. No marks. For the next part only here, by drawing stress diagram to the joint C and D, find the stresses in the rod BC, DC, and BD, distinguishing between tension and thrust. For the second part, don't use both Bose notation. Hence means using these, you have to take the answer. Who took the answers of AD, AB stresses by using Bose notation? No marks. කවුද ගත්තේ එහෙම? එහෙම ගත්තද? නිකන් එරියා හදිස්සියනේ. ගත්ත බෝස් ගාන කරන් ගියා මුලින් දැන් අගට. AD BC AD AB හෙව්වන ළමයි බෝස් වලින් ලකුණු නැහැ. බෝස් වලින් හොයන්න කියනවා තර්ඩ් එක. හෙන්ස් කියලා කියන්නේ. එහෙමද කරේ? ඒක තමයි. ගාන කියවන්න ඕනේ. ළමයි so far no question available under this Bose notation of this type. What? Finding the external forces like this and asking to find the stresses of this rod and this rod without using the Bose. That kind of question so far you can't see in past papers. This is another type of question which might come. Now my Bose වලින් කරන්න එපා ලකුණු නැහැ. Hence කියන්නේ ඒකනේ. I told you no. Different types of questions that might ask in the question in the paper, we will do in the papers. One occasion, the paper question should be among them. That's nothing really. Types of කරනකොට paper එකේ question එක ඔකේ තියෙන්න ඕනේ. නැත්නම් ඉතින් ඒගොල්ලෝ ගේන්න ඕනේ වෙන planet එකකින් question එකක්. ඒතකොට අපි එකට strike කරනෝනේ. එනිසා බය වෙන්න එපා. එනවා අනිවාර්යයෙන්. Right. So, people there, we do it like this. Right. It's very simple now. I take the equilibrium of this joint. I draw that one here. A joint here. The rod is this. This way, X we have 350 root 3 over 2. Y we have 400. Okay. I'll take now here, you can see this joint A. Joint A is in equilibrium, no? Joint A is in equilibrium. Then this rightward force should be balanced by leftward force. Then the force coming in the rod, this should be this way. Then only it will have what? Horizontal leftward component to balance this. Okay. That I told when we do the question and in determining the stresses in the rods, one way of determining the stresses that no, I told you, considering the equilibrium of the joint. If somebody keep that in your mind, it's nothing. There are two ways of determining the nature, stress, tension or thrust. One is using the stress diagram and moving along the sides. Other one is what? Considering the equilibrium at the joint. I expressed. That one only here we have to use. So I'll take this as T1 people, this as T2. Okay. Now for the equilibrium of A, once you resolve this way. What do you get? This angle is 30. T1 sine 30. T1 sine 30 should be equal to this. 350 root 3 by 2. Then for T1 we get 350 root 3. Then Lamai, here, this rod has this way. Then the other way, then what is the stress of the rod AD? It's a thrust of size what? 350 root 3. Why? Because we mark it like this, no? Yeah. For the equilibrium vertically, for this 5 marks coming now. 5 marks. When you resolve upwards, 400 upwards equals T2 plus T1 cos 30. T1 cos 30. Here we get T2 minus 125. 5 marks. That means what? This should be the other way. Direction should be the other way. T2 other way means in the rod BA, there's a tension. There's a tension, no? T2 negative, no? The direction should be the other way. Tension. 5 marks. Then you must write them in words. Right? So far we found only T1 and T2 in sizes, but we must explain their nature too. That we write in words. For each sentence, 5 marks. Write down. AD has a thrust of magnitude. AD has a thrust of magnitude. Write down in words. AD has a thrust of magnitude. (350 root 3 newtons). Five marks. AB has a tension of magnitude. AB has a tension of magnitude. (125 newtons). Another 5 marks. Right now? Okay. Now only asking, by drawing stress diagram to the joint C and D. Only for C and D asking to draw the stress diagram. Find the stresses in the rods BC, DC, and BD, distinguishing between tensions. BC, DC, BC, and BD. Yes. Right. Now we'll come to that. Then now we will close this way. Yes. Right. Yeah. I take this range as a this as B. This as C. This as D. This as E. Right. Here this force we know. What is that? 350 root 3. This force. That we can use because we have used that now. We have found that now. 350 root 3 this. 350 root 3. Now draw this diagram there. Okay, right. We'll draw people now like this. EA down to 100. AB 300. Huh? EA. E here. A here. This is 100. This is B here. 300. Right. BC horizontal. This way. Should see should be on this line somewhere. C should be somewhere on this line. CA makes 30. This way. This is 30. Here C. Next one. This joint we prove that. Now come to joint D. CD must make 30 here. This way. On this line makes 30 with the horizontal line. Somewhere on this line we should have point D. CD, no? DE. E is over there. D should be on this. Huh? DE must be this way. Other thing is, CD and DE must be perpendicular here. CD means this. DE means this. Angle between them is 90. Then D should be somewhere here on the line. That CDN, from there D to E, the two lines should be perpendicular. The best thing is what to find the point D. From this E, drop a perpendicular to this. That is the D. That's the D. Right. Right, this way. D. Right. Now we finished drawing the stress diagram. The DE length should be what? DE length should be what, people? 350 root 3. That you have to use. Right, that's all. For this 10 marks coming. Right. Here 90. By BCE triangle, tan 30. This is not BCE. ABC, 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 ABC. ABC triangle. ABC triangle. Tan 30. 300 divided by BC. BC gives 300 root 3. Next one. AC. This is AC, right? This is 30. AC sine 30, 300, no? AC sine 30, 300. AC sine 30, 300. AC is 600. Right. For this and this, both 5 marks. Huh? Okay. Now, if I draw vertical line here, What is this height? CD sine 30. Hmm? This height BE 400. If I produce this way, this line, oh, right? Tell me what is this whole height from here to here? CD, this height sine 30. From here to here, 400. For the whole height, CD sine 30 plus 400. Yes. Tell me that same height. Hmm? Here 30. This is 90. Therefore, this is 60. Therefore, this is 30. Tell me the same height using DE. DE here 90, no? DE, this is 30. This height DE equals 30. Understand? Then you get this CD. Hmm? Yes. You can write. CD sine 30 means this height plus from here to here 400 is equal to what, people? DE cos 30. DE cos 30. You know DE. Okay. Put that here. DE what? DE we know 350 root 3. This one. Earlier we found that, no? By simplifying this, you get CD 200. CD you get 200. 5 marks for this. All right. Now we found all the sizes. Right now, prepare the table. Rod size, nature, tension or thrust. BC, CD, BD. BC rod given by BC length. BC length 300 root 3. CD given by CA 600. BD given by CD, just now we found 200. Right. Nature, how to do. Right. People, this 300 down, no, should be balanced by upward force. The joint C need upward force. Therefore, it should be like this. Then only it will have a vertical component and balance. Other way, this is a thrust. If this has rightward component, to balance this, we have to have this way. This is a tension. Right? So now this you have to determine. CD, look at this CD. CD. We stand on joint D, move this way. CD anticlockwise, turn anticlockwise. CD this way. CD this way. What is our rotational direction? C, D. Now the stress diagram move from C to D. C to D. We stand on the joint D. CD is the force inside this. Now moving from C to D, find the distance direction. C, D. This way we have to move this way. This way. When we stand on D, we have to move this way, means it should be like this. First tension. BC tension. CD thrust. BD also thrust. No? For this another 10 marks. Right. Right. We have another one question 11 and part A. After break we do. Okay, come to this question number 11. No? Yes. Question 11. Vector question. In the vector question, there was a small mistake in the paper, but corrected one is available here. Hmm? Paper number 16, 15. 15, question number 11. Hmm? In this paper, I think this was missing. I read the question number 11. There you are given this way. The missing part you can write down like this. Thereafter, I corrected that and distributed in chemistry class. If you have that copy, no need to change it. Huh? ABCD is a trapezium such that AD is parallel to BC. DAB pi by 2 and BC equals KAD, where K is a constant. The point E is on BC. That is missing. The point E is on BC such that BE equals 2EC. And F is the midpoint of CD. F is the midpoint of CD. I think that is the missing part. First part, okay. Let AB vector simple A and AD vector simple B. Prove the following. First part, okay. The point E is on BC such that BE equals to EC and F is the midpoint of CD. That part missing in the given paper. Hmm? Right. So many students try to get that answer because of lack of data. You couldn't answer that, but no free marks coming. Hmm? Right. We'll come to that question. Yes. Question number 11. The trapezium I'm drawing now here. A, B, right. This is C. Right. Simple A, simple B, right. Point E is on BC, BE to EC. BE is equal to 2 times EC. BE is 2 times EC. That means when EC is 1, BE is 2. 2 is to 1. No? Okay. We are given this AB vector, simple A, AD vector, simple B, BC vector, K times AD, no? Simple B. BC KAD, BC KAD. We are given in the question BC is equal to KAD. BC is equal to KAD. Then BC vector is KB. Okay. First one asking AE. AE, right? AE vector is equal to AB plus BE. AB plus BE, right? AE vector is therefore AB vector is equal to BE vector. You can write, how to write BE vector as a part of BC? 2/3 BC, no? 2/3 BC. BE 2/3 BC. 2/3 BC. DAB pi by 2 means it's also 90. Yeah? BC vector we know KB. Put that KB here. KE equals A plus 2/3 BC KB. 5 mark coming for this. Simplifying this, we get AE. AE vector is 3A plus 2 KB by 3. 5 marks. Second one asking BF. What is F there? F is the midpoint of midpoint of CD. F is the midpoint of CD. This is F. Asking BF. How to write BF? BF you can write BC plus CF. BF. BC vector KB. See, F vector you can write, since F is midpoint, CD by 2. CD vector by 2. Half CD. 5 marks for this. Then BF we can write K times B half CD vector. People, how to write CD vector? CD vector you can write like this. Starting from C, go to D, selecting any route you like. C, B, B, A, D. This is the route. There you find 3 vectors. That also we can apply. That is called as what? Polygon law of vector addition. We know triangle law, no? Triangle law, we go across 2 sides only. But the same thing is valid. By applying triangle law twice for something, we get what? Polygon law. Correct, no? So then we can write CD vector out. CB plus BA plus AD. Same thing. So you can first write this, no? We need CD vector, no? CD vector you can write this way. First find this CA vector. What is that? CB plus BA. Then you know CA. If you know CA, CA plus AD is what? CD. Once we apply twice the triangle law, we get polygon law. We'll apply that once. CD vector is therefore CB vector plus BA vector plus AD vector. Like this. For this 5 marks. Right. CB means what? CB means minus KB. We write then BF vector is KB plus half. CB means minus KB. BA minus A. BA minus A. This is plus B. Simplifying this, we get BF. BF, you can take half out. K plus 1 times B minus A. 5 marks for this. Right. You are given this way. If AE and BF, AE and BF perpendicular to each other, prove that. Here 90. Right. Okay. Right. First, you know, AB and AD perpendicular, no? AB vector is perpendicular to AD vector. Therefore, what can you say? AB vector dot AD vector should be 0, no? When two vectors are perpendicular to each other, dot product is 0, we know. AB vector, simple A, AD vector, simple B equals 0. This we use, right? For this we get 5 marks. Given AE vector perpendicular to BF vector, given. When two vectors perpendicular, people, you know, the dot product of the vectors is equal to 0. AE dot BF is 0. AE vector we found here, no? Here we have AE vector. Here we have BF vector. Substitute here. AE, BF. AE vector 3A plus 2KB divided by 3 dot. Okay. BF vector half K plus 1B, K plus 1B minus A equals 0. Then this half and this 3. 1/3, no? 1/6, no? We can multiply. Ready? 1/6. Now we have this into this. 3A plus 2KB dot A plus 1B minus A should be equal to 0. Right. This is 1/6, not 0, no? Therefore, this dot product should be 0. How to use the distributive law here? First, take dot product between these two. Between these two. Between these two. Between these two. Use the distributive law of dot product we learned. That we learned, no? All right. Then take the answer. This is what? 3K plus 1. What? A dot B. Okay. Next one. Plus and minus minus 3. A dot A. Next one. This and this. 2K times K plus 1 B dot B plus and minus minus 2K B dot A equals 0. People, we know here we said A dot B 0. This is 0. This is also 0. Right. Then we get this minus 3. What is people? A dot A. A dot A means what? Mod A squared. No? A dot A mod A squared. 2 times K plus 1. B dot B means mod B squared equals 0. Right. Here, you get marks for this. 5 marks. Expansion using distributive law for this 5 marks. And getting this other 5 marks. Mod D square means what, people? Yeah. Vector A means AB vector. Mod simple A vector means AB length. Hmm? Hmm. AB vector is simple A. Mod simple A means what? AB vector mod. AB vector mod means AB length. Then what is this? AB length squared. Okay, AB length squared. What is this B? Vector B is this AD. Vector B modulus means what? AD length. AD length. We know that. Put that there. Minus 3. Mod A means AB squared. Plus 2K times K plus 1. Mod B squared means AD squared equals 0. What is asking there? For this also you get another 5 marks. Asking the ratio AD divided by AB, no? Divide this by AB squared. What do you get? Minus 3. Takes the right hand side. 2K. You get minus 9. K plus 1. AD squared divided by AB squared. Minus signs we can cancel down. Subject AD divided by AB. What do you get? 3 over 2K. K plus 1 root. 5 marks for this. Very easy question, no? If you had that data. Oh. Right. What is the next one asking? If AD is to AB equals 5 is to 4, find the value of K. Hence find AE and BF. Hence find AE and BF. Right, correct. We'll count that. I guess this. Huh? Okay. AD AB ratio of 5 is to 4. AD AB given as 5 is to 4. It means what? This means AD divided by AB. This means AD divided by AB equals 5 by 4. But AD divided by AB over there we have 3 over 2K K plus 1 5 over 4. Right. Okay. Square this. Now, for this you get 5 marks. Square in this. What do you get? 3 over. The root will eliminate left hand side. Right hand side 25 over 16. Right. This and this you can cancel down. 8. Now using the cross multiplication, removing the bracket, bring all the terms to left hand side. Then you get a quadratic equation in K. Right. You get a quadratic equation in K. What is the quadratic equation there? You get, it is this 25K squared. I'm not going to show those tips, right? You should be able to simplify them, right? This is what we get. Minus 24 equals 0, 5 marks. Factorize this. The factors come in like this. 5K minus 3, 5K plus 8, 0. For this also, other 5 marks. By this we get K 3 by 5, K minus 8 by 5. For this 5 marks. We are given K positive, no? not given positive. Yes, K should be positive. K is a positive value. Reason, we are given somewhere BC KAD. BC equals KAD, we are given, no? Then if this K is negative, since this AD is a length, negative, this is positive means this is negative, then BC is negative. BC can't be negative because it is a length. Therefore, K should be positive. Since K positive, we select for the K this. K equals 3 by 5. Right. Yes, for this only, we get these 5 marks. Right. Now, ask him what? AE and BF. We know K. AE, put here the K value. We get AE. BF, put K value here. This 3 by 5. Then take the two answers for AE. We get for AE then, after substituting this K value over there, AE comes as A plus 2 upon 5B for this 5 marks. For BF, same way, substituting for K, we get BF is equal to half 8B over 5 minus A. This is the next answer, 5 marks. Right. That's the end of that question. It's second part. Right, part B, coupling forces. Part B, coupling forces. Right. Count that. Okay, no? ABCDEF is a regular hexagon of side 1 meter. Forces given this way. Across the sides is along the directions of the order of the letters. Find the magnitude and direction of resultant. Find the distance from A to the point where the resultant cuts the line AB or AB produced. Find the force which must be added to the system to reduce the system of forces to a couple of moments, 72 Newton meters in anticlockwise. Right. We'll first draw. Right? This is the hexagon. AB, CD, EF. Forces acting on sides AB, BC, AB root 3, BC 2 root 3, okay, CD 3 root 3, right. FC 4 root 3, no? This, it is 4 root 3. And this EA 3, A90. Find the magnetic direction of resultant, right? You know, exterior angle of a regular hexagon, 60. This is 60. Interior angle, 120, right? Here, this is 90. This is 30, the upper. This is also 30. Right. Now, resolve forces. Resolving forces rightward. Root 3, 4 root 3, 5 root 3. Root 3, 4 root 3, 5 root 3, 2 root 3 cos 60. That means root 3, 3 root 3 cos 60 minus 3 root 3 by 2. No? Yes. This force vertical, no. Write on x. Root 3, 4 root 3, 2 root 3 cos 60 minus 3 root 3 cos 60. Right. 5 root 3 minus root 3 by 2. We get x this way. 9 root 3 by 2. 5 marks. For this. Write in this 5 marks. Resolve vertically. Why? What do you get? 2 root 3 sin 60. 3 root 3 sin 60 minus 3. 2 root 3 sin 60. 2 root 3 sin 60 plus 3 root 3 sin 60 minus 3. For this 5 marks. When you simplify this, we get y. 9 by 2, no? For this also, another 5 marks coming. Asking what? Magnitude and direction of result. No? Yes, magnitude and direction of result. This way we have y, 9 by 2. This way we have x, 9 root 3 by 2. Their result is this, r, a90. Let this angle be alpha. R going to be what? Square root of 9 root 3 by 2 perfect squared. 9 by 2 perfect squared. 9 by 2 perfect squared you can take out. 9 by 2 perfect squared, when you take out, we get 9 by 2. Root 3 squared is 3, 1 squared is 1. Then this is nothing but 9. Newton, 9. For this, you get 5 marks. This, another 5 marks. Direction also asking, therefore, tan alpha should be found. Tan alpha. Tan alpha, 9 by 2 divided by 9 root 3 by 2. This and this you can cancel down. Tan alpha 1 over root 3. 1 over root 3 means 30. 5 marks. That. Okay, now what is next? Find the distance from A to the point where the resultant cuts the line AB produced. Yes. Now I'll mark the resultant force on the line AB produced like this. This way I take marker. I mark it like this. Resultant force has two components: vertical 9/2, horizontal 9√3/2. I'll mark that here. Okay. I mark only the component form. Y, this way X. XY we know. Now I take moment around A. We need to find this length. That length only we need to find. Let us take that length as L. L. Now we take the moment around A. Okay. Right. Just 2 root around A, this 2 root 3 anti-clockwise moment. 3 root 3 anti-clockwise moment. 3 doesn't give. 4 root 3 gives clockwise moment. That should be equal to what? Moment of the result. Okay. That should be equal to moment of the result. Around A clockwise. How take here? 2 root 3 we resolve here. 2 root 3 cos 60 passing through A no moment. 2 root 3 sin 60 this way, it is perpendicular to this AB. Perpendicular distance is 1, no? Side given as 1. 2 root 3 sin 60 into 1. 2 root 3 sin 60 into 1 because side of the hexagon given as 1 unit, no? Yes. 2 root 3 sin 60 into 1. The distance is the 1. By this 3 root 3. So if I join A and C this way, if you join A and C this way, here 120, no? These two sides equal means this is 30, this is also 30. Since this whole angle is 120, if this is 30, this is 90 now. That means to this 3 root 3, perpendicular distance from A going to be this AC length. How to find AC length? Drop a perpendicular from this B on AC. Here. This is 1, this is 30, therefore this is 1 cos 30. This is 1, this is 30, therefore this is 1 cos 30. Then 2 cos 30. 3 root 3 into 2 cos 30. Right. 4 root 3 gives us here clockwise moment minus 4 root 3. This is 90 really, people. This is 1. This is 30. Therefore, this length is 1 cos 30. 4 root 3 into 1 cos 30 means cos 30. This is the algebraic sum of the moments of the forces. This is equal to what? Moment of the resultant. Resultant I resolved into two components, x and y. X passes through the point A, no moment. Y is already perpendicular to this AB, gives anticlockwise moment. Y into L, y is 9/2. 9/2 into L. Right, this way we get. For this equation, you get 5 marks, moments equation. Simplify this. L, we get 4/3 meters. I'm not going to show you the simplification. You can do this. 4/3 means more than 1. That means the resultant cuts AB produced. 4/3 meters. Huh? Okay. What is asking last? Right. Now, I can summarize the situation like this. This is the given hexagon. Right. For the hexagon, this. Right. For all the given forces, we have now resultant force like this. What is that? We found the resultant force to be but 9, no? 9. This angle 30, we proved this. Okay. Right. Then instead of all those forces, I can take their resultant force. What is this length? This length is from here to here 4/3, no? But this length is 1. Then what we get? 4/3 minus 1. 1/3. 1/3 meters. Huh? This length is 1/3 meters. Right. So now we take things like this. We have a single force. Instead of these all forces, now resultant can be used. Single force. 9, size is 9, making 30. From this point, 1/3 meters. What is asking there? Yes. Find the force which must be added to the system to reduce the system of forces to a couple of moment 72 meters Newton meters in anticlockwise. We must add another one force to this. Then this force and new force together make a couple. That couple should have the anticlockwise moment. Then in order to make a couple, the force we supposed to add should be equal of this same size 9. That should be opposite to this direction. That should be parallel to this. Am I correct? So therefore, what I do is this. I put here the force 9 this way. Okay. Definitely not to make a couple, the two forces should be what? Equal, opposite, parallel, non-collinear. Right. Then this 9 and this 9 now give anticlockwise moment. Now we need to find what? This length. Suppose D. Now these two together should form what? A couple in anticlockwise sense of size what? 72 Newton meters. This is equivalent to what? 72 Newton meters couple in anticlockwise sense. You know, when we consider a couple, moment of a couple is a fixed value around any point on the plane. Then we know the new force we have to apply, its size we know, its direction we know. Thing is the point. If we can find this distance, this point is B, then we can explain the force newly we have to add to the system to bring the system to a anticlockwise moment couple. The size of the force is 9, its direction is opposite to this 9, and the point of action we should find. For that only we need to find this D. To find this D, what I do is, people, I take moment around this point, suppose X. Then this doesn't give. This gives what? This gives what? Anticlockwise. No? We are asking to what people? Clockwise or anticlockwise? Anticlockwise, yes. Then this 9, we have take moment. This 9 we reduce, but resolve this way. This way we resolve. Vertical downwards we resolve. This is passing through the point x normal mean this is perpendicular. What is this component? This component should be y component of this 9, no? It is known as 9 by 2. Take moment around this. Hmm? Yes. Then once you take moment around this point, what do you get? Moment of the couple of any point of the plane of the couple is same. Then we get 9 by 2 into d plus 1/3 should be equal to what? Around this point, we'll take moment, that should be equal to 72. Okay. Then you can cancel down. 8 d plus 1/3. 16 minus 1, 16, no? Okay. Then what do you get? This d 47 over 3 meters. Right. For this, you get 5 marks. Right. For this, you get 5 marks. Then how to explain that force? Find the force. This is the force. What is the force? 9. Parallel to what? To certain force. Direction? Opposite. At a distance? What? That d. 47 over 3. Now you have to explain that to get the final 5 marks. Right. So therefore, write down. Therefore, the force which should be added to the system, is a force of size 9 Newton, a force of size 9 Newton, parallel and opposite to the resultant, parallel and opposite to the resultant, acting at a distance, acting at a distance 47 over 3 meters from B, on BA produced, on BA produced. Right. For that, another 5 marks. That way, you must finally write size, direction, point of action, including them, you must write finally. That's the end of part B. Okay, now part A. Part A. Come to part A. Part A, right? Okay, part A, question number 1. Right. Okay, given it is required to keep a particle moving with the given velocity v in a horizontal circle of radius r by means of a string attached to the particle end. Yes, simple thing, no? So the point must be at a distance g r squared upon v squared above the circle, right? Circular motion part, huh? This is circle, horizontal circle. Hmm? Yeah, yeah. Right. Radius r. mg, tension T, this is velocity v. This is r. Right. Let us take this angle as theta. What are the equations we can write? Particle is vertical equilibrium. T sine theta equals mg. Apply F equals ma towards the center. That's all. Right? For the diagram, 5 marks. Huh? Resolving this way. T sine theta is equal to mg. Number 1, 5 marks. F equals ma towards center. අනේ ලියන්න. පොඩ්ඩක්වත් ඉන්න බෑ. ලියන්න ඕනේ. Right. T cos theta is the centripetal force. Centripetal acceleration, v squared over r. Mass is same. V squared over r. Number 2, 5 marks. Divide 1 by 2. T and T you can cancel down. Sine by cos tan. Tan theta. M and M you can cancel down. G r over p squared. For this 5 marks. But what is asking? If you take this as O, this point taken as A, we need OA. We can write tan theta by the diagram. How? OA divided by R. Tan, substitute for tan theta. GR over P square, OA by R. With this way here. OA, GR squared upon P squared, no? Yes. Final 5 marks for this. You know, for part A questions, only 25 marks you get, huh? GR squared, OB squared. Second question. Who did the part A? Right? People now, when you take the paper, first read the paper during 10 minutes from A to Z. Yeah. Don't go to start from always part A or part B. Best thing is, while you are reading, if you find very easy questions that you are so familiar, right? And you have a confidence of getting the answer quickly, start from that question. So once you get the answers, then of course, your stress feeling, you can little by little get rid of your body. The live mind in this examination situation is very important. Otherwise, what happens? Other points, if you get stressed, what happens? Your stress means your mind is not naturally working, not working lively. So that occasion, most of the things, of course, you forget. So therefore, it is not a rule always to start from part A and then part B. No such rule. So I can remember 5, 6 years back, one student, not my student, but I have a certain relation. So his teacher asked him to do first finish part A and then go to part B questions. The student, of course, obeyed that way. He did part A, but one question stuck. He saved there more than I think according to his words, 40 minutes. Then he took nearly 1 hour and 45 minutes to finish part A. Another 1 hour and 50 minutes for the rest. Pointless. Don't, teachers should not give such full instructions. Always the time is limited, people, 3 hours. Without wasting time, people, you should be able to pick marks. My advice is this. Read the question very carefully. It will take in 10 minutes. Once you very carefully read, you will find some questions. You are so familiar, you can take the answer. You are having a good confidence. Wherever it lies in the part A or part B, right? Answer them first. Then without wasting time, you have picked some marks. Understand? Now you have saved time, and meantime, you pick marks, and then your brain or the mental also now relax. Now go for the other questions. Once you do those questions and once you get marks, of course, other questions also you read available in your mind. While you are doing those questions, meantime, you think how to take the answer for the other questions I read here. Once you get answers, now you are positively thinking, you are happy, then little by little, lively, all things, while you are doing other questions, the required data to take the other answers, you can little by little remind. As a result of that, most of the time, you can write almost all questions. That is how people, we save time and pick the marks. Understand? So therefore, don't go to start as a rule, part A I first finish and then go to part B. Nonsense. Don't do like that. එහෙම කරන්න එපා ළමයි. මම නම් කවදාවත් ළමයින්ට ඒ වගේ ගොන් ඇඩ්වයිසස් දෙන්නේ නැහැ. මම කියන්නේ ළමයි පේපර් එක කියවන්න. පුළුවන් හැම ක්වෙස්චන් එකම කොහේ තිබ්බත් කමන්න කරලා මාක්ස් ටික ඇඩ් කරගන්න. ඊට පස්සේ ලේසිලි කරන්න. Otherwise what happens? First if you try to finish part A, wasting time, no answers coming. Then once you go to the time, no time to do other questions, that is enough to destroy what? The rest time. තේරුණාද? එනිසා ඒ ගොන් වැඩි කරන්න එපා. පේපර් එක හොඳට කියවන්න ළමයි. අපි කට්ටිය ගත්ත ගමන් පේපර් එකේ පාර්ට් T දානවා ලියනවා. සමහර ළමයි නමවත් ලියන්නේ නැහැ ක්වෙස්චන් පේපර් එකේ උඩ. අනිත් දවසේ මම බලන්නේ නැහැ. There's a cage to what page number, put cage to what your name. Don't write unnecessary names. Your own name you must write. Right? Bintin, no, whatever, no, your own name. You know the people who wrote Bintin, no. Don't write like that, your own name. Really, I knew some names of you by going through your answers. Until then, I don't know. Some names I can remember now because of the paper. Then only identify you. This guy is okay. So therefore, every paper, your name in the cage where you are given to put the paper number, page number, you have to put them. Right now? Right. And remember, if you need extra papers, you can collect that here. And your rough workings also, as a practice, join toward end of your answers as a practice. Right? Rough working is very important sometimes. Why reason? Right? This usually happens, this issue, this error. At the examination, till the last moment you write no. Your answers, proper answers, papers and the rough working papers sometimes mix up. I have one experience, one teacher, right? He is of course now working with us. He said that he did the paper, he did all the questions, right? Among the rough workings, he had one answer of one complete question. Those days, of course, usually rough working papers is taken away, collected by the examiner there. Now advised to what? Attach them also. That master, of course, couldn't attach that proper answer script to what the handed over answers. As a result of that, he lost what? One question marks. Maybe this is suddenly when you do these things, maybe happening. So therefore, best thing is when you answer, your proper answers keep on one side. Rough workings, you have to put other side. Okay? And right. Finally, go through the rough workings and see whether there are, by chance, mixing up proper answer sheet. If not, you are sure then no need to give that. Otherwise, attach that to the answers. Okay. Then the one who mark your paper, go through them also. If they find there's a certain question with the answers, they will take that and attach to that and give the marks. And saying this, don't take others rough working papers and attach to your one. එහෙම කරන්න එපා. ඒක කොපි කරා කියලා එනවා. ඒව ලකුණු හම්බ වෙන්නේ නැහැ. එහෙම කරන්නේ නැහැ. මචං උඹේ ටිකක් දීපන් කියලා ඔක්කොම තියෙන ඔක්කොම දාලා මොනන්න එපා ඒක. එහෙම කරන්නේ නැහැ. Right. Okay, right. Question number 2. Number 2. Ball is raised from rest at a point A of height h, rebounds to height 2/3 h. All right. Here A, suppose, right, falls from height h. Right. Right. Suppose here it comes to ground with velocity u, suppose. Then it is rebounding with what velocity, people? EU, no? After hitting with the ground. Now it goes to 2/3 h, this height. Two-third h, right? Then we will find this u. How? Apply v squared equals u squared plus 2as. This is drop, no? Initial velocity is 0. 2gh. U equals square root of 2gh. 5 marks. For this motion, here, final velocity is 0. We apply v squared equals u squared plus 2as upwards. Final velocity is 0. U means now EU. EU perfect squared minus 2g. H means 2/3 h, no? Okay. By simplifying this, you can find E. E you get as 2/3 root 5 marks. Right? Now what is asking? Find the velocity with which it should be projected from A so as to just reach the point A after rebound. This information is sufficient to find what? E. Right. Now, we take like this. Okay. Suppose this way. We project somewhere here with a certain velocity that we will find. Once it projected this way, suppose it comes to the ground with velocity this way, v. Right. Then it is rebounding with what? V and rebounding with EV, no? EV. Right. Right. I take this as W. Then W is EV. Right. With this W velocity initially, it should go to what? The same height h. All right. Now we'll find W. How? Apply v squared equals u squared plus 2as. It should just reach the same point of projection of height h. Then v should be 0. U means this W. W squared minus 2gh. We get W as what? 2GH root. Right. Right. Now this W is known. Between W and V, the relation is this. Then we can find this V. Okay. We can find this V. Therefore, V. For this, we get 5 marks. Huh? Okay. V equals W equals E, we know. Then V equals W over E. W. 2GH. E. E means that answer. We get root 3 by root 2. Then we get V. This and this we can cancel down. 3GH root, another 5 marks. Right. Now, to get this velocity V, after following a height h, now we need to find the velocity here initially. Let us take that as what? U. U W dash. Okay. We project with initial W dash. Once it comes to ground, falling height h, the V should be what? This much. That W dash only we need to find. We apply V squared equals U squared plus 2AS download. V squared should be this. What is that? 3GH. U is the unknown we need to find. Plus what? 2GH. Then what is U? U going to be the root of GH. 5 marks. With this velocity, it should be projected down. Not U, it's W dash. No, I took W dash. 25 marks coming like this. Okay, question number 3. ABCDEF is a regular hexagon of side A. Forces acting like this. Show that the 6 forces are equivalent to a couple and find the moment of the couple. How to show a system of forces reduces to a couple? Resolve horizontally, resolve vertically. Show algebraic sum of the components of forces 0. That says what? No result. That says what? Either the system of forces is at rest or equilibrium or reduced to a couple. In order to show there it is really reduced to a couple, we have to take moment around any point and show that moment is not 0. Then no resultant force, but there is a moment that has only for the couple. Right? Correct, no? Yes. Right. So the diagram there. Right. So next Wednesday we don't have the class, and this Saturday also we don't have the class. And the one day I take to finish for the integration in the theory class. Huh? Yeah. Well. Okay. If it is regular hexagon, this way forces act. All right. This way, regular hexagon we have A, B, C, D, E, F. Force P here, 2P here, 3P here, again 2P here, again 5P here, and 4P here. Right. Even now here, when I join these diagonals, the diagonals meet at a point like this. This is called as the center of the hexagon. the perpendicular distances to any side from the center, when you drop a perpendicular, the same length available for every term from the center. So once you take the moment, we can take moment around this point, no, of the system, right? Now resolve horizontally. This way we can resolve x p 2p 3p, p 2p 3p. Here 2p cos 60, 3p cos 60. Cos 60 is half 5p by 2. Okay. What is this? 4p cos 60 minus 2p, 5p by 2. No? Minus 2p minus 5p by 2. Other four sign is, what's that? This for the process, no? 2p, 3p, 2p. 5p by 2, 3p, 2p. Cos p here, 2p here, 3p here, 2p here, 5p here. I mean, this is 6p, no? Not 4p, 6p this. Yes, 6p. 6p cos 60 means this is 3p. Correct, no? Correct. 6p cos 60 minus 3p. Right, this one. What is this? This we can cancel down 0. Resolve vertically. Why? What do you get? Here, 6p cos 30, 2p cos 30. 8p cos 30, no? Here, 5p cos 30, 3p cos 30, minus 8p cos 30. Minus 8p cos 30. Again, 0. For this 5, for this 5. Right. Now, here, x0, y0. Is it sufficient to say this system of forces reduces to couple to say? No. X equals y0 means resultant 0. Of a system of forces, resultant can be 0 subject to 2 reasons. What? Is a system of forces equilibrium? R0. If it reduces to couple, again R0. Then in order to verify that, we have to show what? Moment. We'll take moment around this O. Okay. What is side? Side given as A. A. The side is A. Then what is this? You know, this triangle OAB is a equilateral triangle. All the triangles equilateral. If this is A, this is 30, or this is 60. What is this length? A sine 60. A sine 60. Or cos 30. Root 3 by 2. Right. You know, to every side, this is the perpendicular distance. We'll take moment around O anticlockwise. What are the anticlockwise moment force? P, 2P, 5P. Okay? We write P, 2P, 5P. Into what? This length, no? This length, no? Moment? Yes or no? I am not going to multiply that yet. Clockwise moment? 2P, 3P, 6P. They give clockwise. Right? 2p, 3p, 6p. Then to find this anticlockwise moment, this should be multiplied by what? The distance, this, no? This should multiply by what? Same distance, no? The distance is common, no? Take that out. Put here minus sign because this is clockwise moment. Here we have what? Root 3a by 2. Correct, no? What is this? 8p. Here? This 8p minus 3p. Minus 3p into what? Root 3a by 2. Around O, anticlockwise moment is negative. Then what is clockwise moment? It has clockwise moment like this. 3 root 3pa by 2. Right. There's a moment. No resultant. No resultant. There's a moment means what? Now only we can say system reduces to a couple. Right. I don't know. Right. For this 5. For this 5. Okay. Now last 5 you get how? Right in words. But therefore, now only we can say what? Resultant 0, there's a moment. Therefore, system reduces to a couple of moment 3 root 3pa by 2 clockwise. Right now, for that 5 marks. Therefore, system reduces to a couple of moment 3 root 3pa by 2 clockwise. Or clockwise moment that. 5 marks. Question number 4. Two forces of magnitude 3p, 2p respectively have resultant R. If the first force is doubled, the magnitude of the resultant is also doubled. Find the angle between the forces. Find the angle between the forces. Okay. This force 3p. This is 2p. Then the angle between them is theta. Resultant is R. Right. Next one. If the first force means 3p, no? 3p is doubled. It becomes now 6p. 6p. This is still 2p. Resultant is 2r. Now, resultant is doubled. This angle be theta. Now, what is resultant formula? Okay. R squared. What? Square of this plus square of this plus 2 times this into cos theta. No? Right now. Square this 9p squared. Square this 4p squared plus 2 times. What? This and this. 3 to 6 and this 2 12. 12p squared cos theta. Number 1, 5 marks. For that, write down 4r squared 36 p squared 4 p squared 6 and 12 24 p squared cos theta. Second one, another 5 marks. Divide by 2 by 1. Hmm? Then we get 4 equals here 40 p squared, 24 p squared cos theta. Here 13 p squared, 12 p squared cos theta. For these 5 marks. Okay. And use the cross multiplication. That you get something there. Right. So that 5 marks. Then you get cos theta by solving that minus half, giving theta 120. Final 5 marks coming to this. Right. Work power energy, next one. Right. Engine of a car works at power h what? The resistance to the motion is R. If the velocity of the car is V, find its acceleration. Mass of car is M by U. How? Very simple question. No? Now 5. This way, the car available. Moving with velocity V. Engine of the car work at the power H. People, how to find the tractive force F? F is given by what? H equals F V, no? Then F is H upon V. H means the power. In what? Velocity is V. And given resistance R, mass of the car is same. Asking to find what? Acceleration. Right. Finding this 5 marks. Okay. Apply F equals MA this way. H upon V minus R M times A. Okay. For this, you are given 10 marks. And subject in A, 1 upon M, H upon V minus R is the acceleration. This is another 10 marks. That is 2 short question. Number 6 next. Right, no? Question number 6. Two bodies A, B move with velocity speed root to U, respectively in direction given by the vectors. Oh, right. Right, people. A moves with velocity root to U, meters per second. In what direction? In the direction of the vector I plus 3j. B moves to U, meters per second. In the direction I plus 2j. This way. Okay. Show that by using vectors, the velocity of A and B are this. People, when we write a vector, AB vector, when you write, how do you write AB vector? AB vector modulus multiplied by what? Unit vector in the direction of AB. No? This way. Like that, A has the size of the velocity is root 2u. Its direction is direction of this. Velocity means what? Vector. Then velocity vector of this A, velocity of A, if we denote by VA, tell me how to write this velocity of A? Velocity means vector. Size you must write here first. It is given here as root 2u. The concept of direction, how to include here? This should be multiplied by what? Unit vector in the direction to A moves. This is the direction to which A moves. In this direction, we have to find the unit vector. When you are given a certain vector, alone that direction of the vector, how to find the unit vector? How to find the unit vector? Yes? Bring this where here? That vector should be divided by what? Its modulus to find what? The unit vector along that given direction of the vector. Okay. So therefore, velocity of A, okay, size is this. This should be multiplied by what? Unit vector in the direction to which A moves. This is the direction. In this direction, how to find the unit vector? This vector should be divided by its modulus, size. How to find the size of a vector having ij? We divide this by what? We take what? I coefficient squared plus j coefficient squared root. So therefore, velocity of A can be found how? Multiply the size by what? Unit vector I plus 3j divided by what? 1 squared plus 3 squared root. No? What is this? Root 10. Here root 2. Cancel down. Here we get root 5. U over root 5 I plus 3j. Is it? Yes. U over root 5 I plus 3j. Okay, no? VB, velocity of B, same way. It is given to you. What is the unit vector? This I plus 2j should be divided by what? 1 squared plus 2 squared root. What's this? 2u over root 5 I plus 2j. Right. We wrote like this. Now, what is this? What are these velocities? Velocity of A relative to Earth. This what? Velocity of B relative to Earth. No? No? Right. Now, what is asking? Show also that velocity of B relative to A. Velocity of B relative to A. Velocity of B relative to A asking. Velocity of B relative to A, we write like this, no? Velocity of B relative to A. Velocity of B relative to A, how write? V B E plus V E A. E A. No? These two we can interchange, no? E A. A. No? E A we can change as A. Thinking minus sign, no? Right. V B E minus V A. Right. We know B E, we know A E. Put them there. B E 2u over root 5 I plus 2j minus VA u over root 5 but I plus 3j. Correct, no? So marks come in like this. Yes. Finding these two unit vectors, 5 marks. Right. Writing the vectors related to Earth this way, each 5 marks. Writing this 5 marks. Now simplify and take in the final answer another 5 marks. Take u over root 5 out. Here what do you get? 2I minus I, it's I. 2 and 2, 4 minus 3, J. For this other 5 marks. Right. Question number 7 next. Correct, no? Right? Okay. Question number 7. Question vector for moving. Nice question. Who did this question number 7? Work from energy using vectors. Who did this? Right? You know, 7. It's a very nice question. So if somebody has a good idea about the mathematics, then only they can little by little convert this to the question. I'll first explain what is work. This way, suppose we have a force F, right? It makes an angle theta with horizontal. Once the action of this force F brings this object, now stop talking, at a distance d. How to define the work done by this force F? Work done by force F. Is it directly F into D? No. First find the direction of displacement. Displacement is horizontal rightward this way. Along that direction, find the component of force. F cos theta. That F cos theta into D is what? F cos theta into D is what? The work. F cos theta into D. Okay. People, F is a vector. Displacement is a vector. Right? If I take, here this F means size. Okay. If I take this force as a vector, I take this way. D, displacement. This way we can, displacement also a vector, I can mark. Then, what is F dot D? D is dot T is the dot product. F dot D, tell me. F modulus. D modulus. What? Cos theta. According to definition of dot product. Yes. F modulus. D modulus. Cos theta. If I take F modulus as F, D modulus as D, this one. F modulus as F, D modulus as D cos theta. We get FD cos theta. This is coming. What's that? Work done by the force. Ahuna. Oh. Ini lamai මොකක්ද ඔය කියන්නේ? Force එකේ displacement එකේ dot product එක ගත්තොතින් මොකක්ද ලැබෙන්නේ? Work done by the force. Then you can write. Work done by the force, W, equals what? F dot D. What? Dot product of the force and the displacement. Hmm? In other words, dot product of force and displacement. All right. Now read the question. Okay. We are given these people. The position vector for moving particle is R. This T is the time in seconds elapsed since the start. A force P acts on the particle. Show that the power generating. Power generating. Power generating. Work is this. All right. W F dot D. Power means what, people? Rate of rate of doing work is the power. Rate of doing work is the power. H should be what? D over dt what? W. D over dt W. Ilya Uama. All right. All right. So then what? H means what? D over dt. People, what is W? F dot D. W is F dot D. All right. So now see here. We are given position vector for moving particle is given by R. People, position vector means what? Displacement. Yes or no? Position vector means displacement. Right. And force is given. Then that given force in terms of Ij put here. Given displacement R, Ij put here. Then first take what? Dot product. Then differentiate that. You must get what? Power H. Take the answer. Then for this 5 marks. 5 marks. പിന്നെ ഗജറാമിന്റെ കഥാവ്. Right. We can take H. D over dt. Right. Okay. F means the force given. What is the force given? 20I plus 15J, no? Yes, 20I plus 15J. Dot. And displacement are Ti plus 2T cube J. Ti plus 2T cube J. Okay. Asking what? Power generating at time T equals 3. First take dot product here. II coefficient multiply. JJ coefficient multiply. H. D over dt. 20 and T, 20T. 15, 30. T cube. Differentiate this. 20. Here, 90T squared. Taking dot product here, 5 marks. Differentiating 5 marks. Right. Identifying W as F into D, 5 marks. This is 5 marks. Then this is power. We need power at what time? T equals 3 seconds. No asking. T equals time t3, put h at t equals 3, 20 plus 9, 3 into 3, 9, right. 8, 10, 20, 8, 30, right, what? 5 marks, right. This is how we take. It's a nice question. You must have definition of work power energy and vectors. It's a good question. Right. මේ වගේ එකක් આવුත් ළමයි ස්ට්‍රයික් කරනවා නේ. මේ වගේම පස්සේ ඉදිරිය යනකොට ස්ට්‍රයික් කරනවා. නේද? අපි ස්ට්‍රයික් අපේ ළමයිට ස්ට්‍රයික් කරන්න ඕනේ නැහැ. අපි කියලා දීලා තියෙනවා. රයිට්. තව වගේ රස questions එයි ළමයි ඉස්සරහට papers වලට. හරි. මේ සැරේ ඒ වැස්සක් තියෙයි. ඒ වැස්සක් තියෙයි නේද? storm of ඒ නේද? නේද? ඉතින් හරිනේ ඉතින් තව ළමයි අපිට මාස කීයක් තියෙනවද? මේ ජූන් ජුලයි ඕගස්ට් මේ ජූන් ජුලයි ඕගස්ට් සෙප්ටැම්බර් 5 months 20 papers කරන්න පුළුවන් තව 20 papers කරනකොට ඉතින් එයි හොඳ ගානට සෙට් වෙලා නේ ගහමු පැහැටි ගිහලා දෙමු පැලෙන්න right okay number 8 the last question තමයි ඔය papers ටික ඔක්කොම කරලා යන්න විවාහට යන්න කලින් ඔය papers ටික කරලා තව මාස දෙකකින් විතර ඔයගොල්ලෝ past papers කරන්න ගන්න 25 වලින් පටන් ගන්න පස්සේ 24 වලින් පස්සට පටන් ගන්න past papers කරන්න යනකොට ළමයි තේරෙයි ඒ වගේ සීනි බොල තියෙන කියලා 10 papers විතර පස්සට කරන්න 15 වගේ වෙනකල් ඇති ඒකල exams වලට යන්න එතකොට ඔයගොල්ලෝ ඔය ටික ඔක්කොම කරපුවාම ළමයි ඔය එන paper එකේ ඔයගොල්ලෝ කරපුවා ඔක්කොම තියෙයි අනිවාර්යෙන් තියෙනවා ඒක මම ඉතින් අත්දැකීමෙන් කියන්නේ අනිවාර්යෙන් තියෙන්න ඕනේ හරි තව papers 20ක් අපි කරනෝනේ ඒවත් එක්ක past papers 10ක් කරන්න යන්නේ අල්ලන දන්න බඩුවක් හම්බ වෙයි. දන්න question එකක් හම්බ වෙයි. Right. Okay, number 8 take. The particle of weight W is placed on a rough inclined plane of coefficient of friction mu. If the inclination is alpha, find the minimum horizontal force which prevent the particle from sliding down along the plane. Right. Sliding down along the plane. Right. Right. This is the inclined plane. This is alpha. Right. Now stop talking. This way we have a normal reaction R. Weight W is here. Right. People, once we keep this object like this, what happens? Particle begins to move down along the plane. Why? The frictional forces first increasing up to maximum frictional force. Thereafter, only this begins to move down. Then we can prevent this sliding of the particle down along the plane practically by applying a force this way. We can stop this sliding particle down along the plane. Asking minimum force of F. And then here the frictional force acting on the particle is suppose F, but this F is less than F max or F lim. Does this slip? We know until the frictional force goes to maximum frictional force, object doesn't slip. We learned like that. Understand? Then, if this particle slips, definitely this frictional force has reached to where? Maximum frictional force, that means definite frictional force. By applying this external force, if this external force F is the minimum value, by applying this minimum force, we must be able to bring this frictional force to what? Limiting frictional force. Understand? Suppose this limiting frictional force is like 2 Newton. To bring this limiting frictional force to 2 Newton, suppose here we must apply 10 Newton. Then this is in equilibrium. What if I increase this force to 15? This frictional force come to what? 1 Newton. Maximum frictional force is 2 Newton. Once you increase this one, this frictional force acting on this is what? Minimum. But that occasion, this force is not minimum. So therefore, the minimum horizontal force should be able to bring this particle to what? Limiting frictional force. That is the minimum force here. Write on the word like this. Right. If the horizontal force is minimum, if the horizontal force is minimum, by that force, the particle should come to limiting equilibrium. Limiting equilibrium. Right. Then tell me what is the limiting frictional force? F equals mu r r, mu r r. Now what we do? Resolve along the plane, resolve perpendicular plane. Take two equations. Right. For the equilibrium, resolve perpendicular plane like this. Here, this angle is alpha. All right. What is this force then? This is R. Other side, W cos alpha. F sin alpha, no? F sin alpha. W cos alpha plus F sin alpha. W cos alpha plus F sin alpha. Number 1. 5 marks. Okay. That statement, put 5 marks. Right? Statement, put 5 marks. Resolve this way. Along the plane. What do you get? Mu r plus F cos alpha equals W sin alpha. Right? Mu r plus F cos alpha equals W sin alpha. Number 2. Another 5 marks. So far 15 marks. Right. Now, you can do the response like this. Here. This R we have in number 1. That R we put where here? Also far this no, that we put here. It contains F. Then this will be F. Here also we have F. Take F out and subject F. And then you get the minimum force F. For that, another 5, 10 marks coming, no? Yes. So far, how many marks? 15 we got, no? Yes. Put this here. For that, 5 marks come in. Put in this R we are here, 5 marks substitution. By that equation, subjective, if you get something like this, W times tan alpha minus mu divided by mu tan alpha plus 1. Last 5 marks coming for this. Right. That's the end of the discussion. So then one day we can do only one paper. But have you ever heard this kind of paper? Some masters, they finished within 1.5 hours. 1.5 hours completely finished for discussion. Then they just show what? We discuss the paper, no paper. This time we take, okay. Then today paper 17 available. What time you can, those who need to do the paper early, they can go to their room number 23 and start. Otherwise, usually we start at 2 o'clock, no? What are the people going now? Stay to write paper. Right, okay. We'll come to the end of the discussion today. And paper 20, paper 17 we write. Proof number 20.